Hi everyone, today we will discuss the very fundamental law of electrostatic that is called Coulombs law. And we will discuss today the magnitude as well as the vector form of the Coulombs law. This is the statement of the Coulombs law. What is the statement says? The force of attraction or repulsion between two stationary point charges is directly proportional to the product of magnitude of two charges and inversely proportional to the square of the distance between them. I just want to repeat, the force of attraction or repulsion between the two stationary point charges is directly proportional to the product of magnitude of the two charges and inversely proportional to the square of the distance between them. Let's consider two charges, one is Q1, another charge is Q2, and these two charges are separated by distance r. These 2 point charges are separated by distance r. By the statement of the Coulombs law, we can write the force of attraction or repulsion is directly proportional to the product of magnitude of the two charges and inversely proportional to the square of the distance between them. If I make it, this is as equation 1, this is as equation 2. Combining equation 1 and 2, I can write F is varies as Q1 Q2 upon R square. If I remove this varies, I must introduce a constant that is called Coulomb's constant, and this K value is nothing but 1 by 4 pi epsilon naught. I just simply want to substitute here this F equals to 1 by 4 pi epsilon naught Q1 Q2 upon R square. If you observe very carefully these things, F is a vector quantity because it is force, but I have not given any arrow mark here. It means it indicates the magnitude of the force. The whole term is nothing but the magnitude form of the Coulomb's law. Now we'll go for the vector form of the Coulomb's law. If I introduce F as a vector, I must introduce as a vector, then I must introduce this Q1 Q2 upon R square one unit vector, because the whole term is in magnitude form. These are the magnitude form, and this unit vector give the direction. So magnitude and direction giving rise to a vector. So this F vector can be written as 1 by 4 pi epsilon naught. This is Q1, this is Q2 upon R square. This R cap is a unit vector. It can be written as R vector upon R. So what is my laws now in vector form? This is Q1, Q2, and this is R vector. So this is exactly the Coulomb's law in vector form, and this is exactly the Coulomb's law in magnitude form. Here one term is coming, that is K. Here K is nothing but 1 by 4 pi epsilon naught. If you observe carefully, this epsilon naught is called electrical permittivity. Electrical permittivity of free space. This is a very fundamental term is coming, that is called electrical permittivity of free space. Students usually have the doubts, the basic definition of the electrical permittivity. Let's discuss what is the basic aspect of this electrical permittivity. If you observe, suppose this is charge Q1 and this is charge Q2. This is charge Q1, this is charge Q2. Suppose this charge, and in between the two charges the medium is air medium. Suppose this charge providing the 100% signal. This charge is providing 100% signal, and due to air medium, suppose 40% is absorbed by the medium and 60% is reaching to this charge Q2. This charge provides 100% of the signal. Suppose due to air medium that 40% has absorbed by the medium and 60% has reached to this another charge Q2. So what the signals that has absorbed by the medium, or you can say the restricted by the medium itself, that is called permittivity of that medium. It means the amount of field lines or the amount of electrical field lines that has restricted by the medium is called the permittivity of that medium. Here 40% has restricted and 60% has allowed. That 60% is not electrical permittivity of the medium. It is 40% that has restricted or resist by the medium, that can be treated as what? Electrical permittivity of that medium. I want to repeat my statement one more time. The amount of field lines that has restricted or absorbed by the medium is called permittivity of that medium. And if you observe this permittivity term, the unit of the permittivity is coming Coulomb square upon Newton meter square. If I go for the dimension, this Coulomb is the unit of charge, and charge can be defined as Q equals to IT. I can be represented as ampere, and T is what? T. So in place of C, I can substitute as AT, but it is square. I just introduced the squares. And Newton, everybody know that is force. And force is what? Mass into accelerations. So I can directly write that M1 L1 T minus 2, and length is L2. If you carefully do these things, it will coming M minus 1. This is L3. So this is L minus 3. This is T 4 and A2. This is exactly the dimension formula of epsilon naught. Most of the board papers, this question probably come that what is the dimension formula of epsilon naught? M minus 1, L minus 3, T4, A2, and what is its unit? C square, Newton meter square. If I and its value is, mathematical value is 8.85 into 10 to the power minus 12, that is Coulomb square upon Newton meter square. Now if I substitute this epsilon naught value here, I can get the value of K. And the value of K is coming as K equals to 1 by 4 pi epsilon naught. So 1 upon 4, this is pi is 3.14, and epsilon naught is 8.85 into 10 to the power minus 12, and I'll get the value. If I do the calculations, all I'll get 9 into 10 to the power 9 Newton meter square upon Coulomb square. Exactly the reverse of the dimension of epsilon naught, because 4 no dimension, pi also no dimension, only the dimension of the K is exactly you can say the unit of K is exactly the reverse of the unit of the epsilon naught. And if someone will ask you what is the dimension formula of K, exactly the reverse of this. So I can write the dimension formula also, M1 L3 T minus 4 A minus 2, because it is reverse of that epsilon naught. Student, please aware of these things. Let me summarize what are the things today we have discussed. We discussed about the magnitude and the vector form of the Coulombs law. What is the law says? The force of attraction or repulsion between the two stationary point charges is directly proportional to the product of magnitude of the two charges and inversely proportional to the square of the distance between them. I consider two stationary point charges separated by distance r. As per the law, I said the force of attraction or repulsion is directly proportional to the magnitude of product of magnitude of the two charges and inversely proportional to the square of the distance between them. Combining equation 1 and 2, I write like this. I introduce a constant. This is called Coulomb constant, and its value equals to 1 by 4 pi epsilon naught. Simply putting here, I just introduce as the Coulomb's law in magnitude form, because nothing has been arrow is given here. If I write f as a vector, I must introduce a unit vector, and we all know the definition of the unit vector, that r vector upon r. So f vector can be written as 1 by 4 pi epsilon naught q1 q2. This is r magnitude q and r vector. Here K is what? 1 by 4 pi epsilon naught. The term is coming electrical permittivity of the free space. And I already said the definition, the amount of field line that has restricted or opposed, or you can say absorbed by the medium, is nothing but the permittivity of that medium. Here the medium is air medium, you can say free space. And epsilon naught unit is Coulomb square upon Newton meter square. And if you observe these things, and I dimension formula this m minus 1 l minus 3 4 a2, and its mathematical value is 8.85 10 to the power minus 12 Coulomb square upon Newton meter square, and k exactly the reverse of epsilon naught, and the value is coming 9 into 10 to the power 9 Newton meter square upon Coulomb square. Exactly the dimension formula of k is reverse of this epsilon naught. I hope the scenario is pretty clear to everyone. Thank you everyone for your watching.